Welcome to Zaption Tour 6-3, Solving Systems Using Elimination. There are 6 boxes. So as we have seen, there are 2 different ways to solve a system of linear equations. We can graph or we can use substitution. Those are the 2 things that we've been studying so far. Yet another way is elimination, and depending on how the system is written, elimination may be the best choice. So this lesson is all about how to solve a system using elimination. Here's box number 1. It's an example, and I call this an easy example. There's easy, medium, and hard. You'll see why I call this an easy example. The directions say solve by elimination. So do you notice right now that in the first equation, which is this top equation, I have a 2x, positive 5y, and a 17. In the second equation, I have a 6x and a negative 5y is equal to a negative 9. Do you notice that this variable, 5y, and this variable, or I should say the variables y, have the same coefficient, 5, but have opposite signs? This is a really important thing to recognize because this is what makes solving elimination easy. If I were to just simply add vertically these two equations, I would get 2x and 6x make 8x. 5y and a negative 5y makes 0. So this cancels out, or the 5y's have been eliminated. That's why we call this the elimination method. And then, of course, if I take 17 minus the 9, I get a positive 8. So we can clearly see, dividing both sides by 8 using inverse operations, that x is worth a value of 1. Now that I know that x is worth a value of 1, I can substitute it back in either here or either here. It does not matter. We can choose either one. So I'll go ahead and do that real quick. I'll choose the top one. 2 times 1 plus 5y is equal to 17. So 2 plus 5y is equal to 17. So 5y is equal to 17 minus 2, or 15. So therefore y is equal to 3. So the solution to my system of linear equations is the ordered pair 1, 3. Example, or box number 2 is another example, and again I call this an easy example. Can you see why I call this an easy example? In the first equation we get a negative 6y. In the second equation we get a positive 6y. If I add these 2 equations up vertically, 5x and 3x make 8x. Negative 6y and positive 6y are eliminated, and negative 32 plus 48 is worth 16. Using inverse operations, if I divide both sides by 8, I see that x is worth 2. Taking that value, substituting it back there or there does not matter. I'll choose the second equation this time. 3 times 2 plus 6y is worth 48. 3 times 2 is 6, plus 6y is worth 48. Therefore, 6y is worth 42. Divide both sides by 6, and y is worth 7. So therefore, the ordered pair point would be 2, 7, and this would be the solution to the system. Box number 3 is a U-try. It says solve by elimination, and again, I'm calling this one an easy example. Can you see why? Hopefully you got the right answer. If not, the solution is negative 1, negative 2. By adding these up, you can see that the 3x's cancel out, leaving you with negative 7y equal to 14. Solving for y, you get y as a value of 2. Plugging it back in, I've substituted it back in for the original equation right here, and I got x is equal to negative 1. Box number 4 is what I call a medium example. The reason I call this a medium example is for the following reason. Taking a look at the signs, so the x variable has a negative 2 in front of it, and the x variable has a positive 7 in front of it. The y variable has a positive 15 and then a negative 5. So what I want to do is I want to choose a variable that I want to eliminate. In this case, I'm going to choose to eliminate the y variable. The easiest way to eliminate the y variable is to make this negative 5y up negative 15. So I have to ask myself, how can I make this negative 5y a negative 15? Well, I would have to multiply the entire equation by 3, because 3 times negative 5 gives me negative 15. So if I do this, I get a new equation. I would get this. 3 times 7x is 21x. 3 times negative 5 is a negative 15y. And then 3 times 17 is 51. Now, just write the original equation right on top of it again. Negative 2x plus 15y equals negative 32. And now you'll notice it's back to being an easy problem because I have the variable y has the same coefficient but opposite signs. So again, I'm just going to add this up like we did vertically before, and it becomes an easy problem. So negative 2x plus 21x gives me 19x. We see the 15s clearly cancel out. And negative 32 plus 51 gives me 19. Dividing both sides by 19, I get that x is equal to 1. Hopefully that made sense to you. Of course, we're not done. We have to plug it back in. I'm going to go ahead and choose and plug it right there. Or I could have chosen to plug it right there. It does not matter. You get the same result no matter what you do. I'll do this in orange for you. So I'll do 7 times 1 minus 5y is equal to 17. Therefore, negative 5y is equal to 17 minus 7, which of course is 10, and y would be negative 2. So the solution to this system would be the ordered pair point 1 comma negative 2. Box number 5 is an example of what I call a hard equation. The reason I call this a hard elimination equation is because taking a look at the variables, I have a 3x and a positive 4x. Those are the same sign and they are different coefficients. Same thing for the y's. I have a 2y and I have a 3y. Well, they don't have opposite signs, they're not the same number. So we have to make them the same number and opposite signs. So we have to make a choice. You can either choose to eliminate the x or you can choose to eliminate the y. In this example, I'm going to choose to eliminate the x variable. So what I do is I say, okay, what is the lowest common multiple I could do of 3 and 4? Well, that would be 12. Okay, so I need to multiply this whole equation by the number 4. And then I'm going to choose to multiply this whole equation by a negative 3. Do you see why I chose a negative 3? Because that's going to give me the opposite sign. So my new equation would be this. This would give me 12x plus 8y is equal to 4. All I did was I distributed the 4 into the entire equation. This equation would give me negative 12x minus 9y is equal to a positive 6. So again, I just distributed. Now we can see that I have a 12x and a negative 12x, so my x's are going to be eliminated when I add vertically. So those cancel out. So I get 8y minus 9y is negative 1y is equal to 4 and 6 make 10. Therefore, y is equal to negative 10. Of course, we're not done. We have to go substitute it back in. I'm going to choose that one and do this in green for you here. So 4x plus 3 times the value of y, which was negative 10, is equal to negative 2. So 4x minus 30 is equal to negative 2. So 4x is equal to, if I add 30 to both sides, I get 28. Divide both sides by 4. I'll come all the way over here for you. And we get x is, of course, equal to 7 on this side. So the solution to my system would be 7 comma negative 10. Box number 6 is a U-try. All I want you to do is tell me how many solutions the system would have. Remember, there can only be 3 answers. 1 solution, no solution, or infinitely many solutions. Hopefully you recognize that if you just multiplied the entire bottom equation by the number 2, you would get this new equation. 2x plus 6y equals 18, which is exactly the same exact equation as the top. So therefore, because I have two equations that represent the same line, there are infinitely many solutions.